Large triangle ABC has side length of 6 and then inscribed in the circle P. And the congruent smaller circles centered at D, E, and F are inscribed in those three regions between the arc of the circle P and a side of the triangle ABC is given. And based on this, what we want is the area of the DEF. Okay, so DEF is just the center of these congruent circles. We just connect those and make a triangle. And that's the area what we are looking for. And so like this is a nice geometry problem, including a lot of properties of the circles, but I will ask you to go ahead and try and see if you can do something and get another way of doing this problem if you didn't try yet. So assuming you just did, and I'll go ahead. So first things that we have to kind of come up with when we are dealing with circles, like finding some intersection and connect the radius, I mean the center point of a circle to those intersections to get some nice figures that we can actually easily handle it. So what I'm going to try, I'm going to take this center point and connect with the point C. And also if I extend this, that will going through the center of the other circle, this congruent circle D, okay, because the ABC is the equilateral triangle. So, and that will give us 90 degrees right here. So since we are told ABC is the equilateral triangle, then I can easily say this is going to be 60 degrees, and this is going to be 30 degrees, and this is going to be 30, and this is going to be 60 degrees, okay? But at the same time, I'd like to get some values. What we have only is the ABC has a side of 6, so which is why that should be 3, and that should be 3 as well. Then you can go with these other ones as well. Okay, so maybe we can find this height of the triangle, because we know this side is 3, and then that's opposite to 30 degrees. If you use the features of the 30, 60, 90, then we already know the hypotenuse is 6, and then C to this intersection is 3 root 3, right? So now we can just label this segment, but before we kind of try labeling those, maybe I can just do such a thing from the other side as well. So let me connect the A to this center, and I can include all the way to the here, but let me stop for now. So the same reasoning, if we were extending this all the way to the center of the F, then this is going to be also perpendicular to CB at this tangency point. So which will be, these two angles will be also 30 degrees. Okay, so since this is 30, this is 90. Now we have another 36 and 90 triangle. So if I name this is X, then this guy would be X root 3. So that means this is going to be 3 divided by root 3. So which will be just root 3. Okay, so now we got that one. And then we already know this was 3. And then C to this intersection was 3 root 3. Since this is root 3, so that means remaining part 2 root 3. Okay. And I think we are almost there. And what we were trying to find is the distance between the center of those congruent circles. So if I take this center and maybe connect with this, if I know this DF, that will be the same for the EF and ED. So then we will be done. So for that, I'm going to connect these as well. So look at the triangle right here. This is a isosceles triangle because PF and PD is congruent, so which is going to be useful. And I do know this was 30, this is 90, so this angle was 60. Since this is isosceles, so that angle is 30 degrees, this is 30 degrees. And I do know this is root 3, and then this is root 3. Maybe I should find the radius of the smaller one, which is also easier because if I name this is like R, then extend this a bit. And then this is also R because that will be diameter of the smaller circle. And from C to this tangency point, that will be diameter of the largest circle P. So which is going to be, this is 2 root 3, this is root 3, which is add up to 3 root 3. And then there is 2R. So this is equal to diameter of the largest circle. But how we can find that, right? So we also know that this is 3 and then this is 3. There are a couple of ways, but one of the ways that I can, this is the diameter of the P. Okay, so we can use the power of points in this case because this is a intersection of this chord and this chord. Now we know this is 3 and 3, so we can just use the power of points. So if you don't know the power of points, you can just kind of take a look at it, and then that will give you 3 times 3 equals the 2r times the remaining part, which is going to be 3 root 3. Okay, so I can cancel these guys. So the r would be, I can cancel these as well. So that should give you just root 3. And r is root 3 over 2. There's another way to find this r as well. So I'm going to leave that for you to explore. But we now got the radius as well. So there is a nice relation, which is you don't really need to memorize. But if you are doing a national level problem or even state level, so it's good to know this as well. So whenever you have like 30 degrees, and this is 30 degrees, if this is x and this is x, this side will be x times root 3. So you can easily confirm by just dropping the altitude. So you will get the 90 degrees, and then this is x. So the opposite will be height, which is x over 2. Then this guy will be x over 2 times root 3. And then the same thing goes right here. So you can get it immediately, but I think it's good to know. So we know that P to D, okay, P to D now is root 3 plus root 3 over 2, which is just 3/2 times root 3. So why this is important? Because as soon as we know this, we may find the df. So the df is going to be root 3 times of this one based on this, or you can just kind of drop the altitude and go from there. So if you multiply this by 3/2 root 3 by root 3, so you will get 9 over 2. So now we know that df is 9 over 2. And if you connect e to f or e to d, that will be equal to df, which is a equilateral triangle because we had the congruent circles and the equilateral triangle in the middle. So that will make the same, like equal to each other, those. So now we have def as an equilateral triangle. And I do know that we can use the area formula for equilateral triangle, which is equal to side squared times root 3 over 4. That's also useful. And if I take the 9/2 as my side, because df is 9/2 times 9/2 like 9/2 squared times root 3 divided by 4. So this is 81 over 4. If you divide 4 by 4, which is going to give us 81 over 16, and then times root 3. So we are looking for a radical form, so that is going to be okay. So the 81 over 16 times root 3. So I hope that was clear. So you can try this question a couple different ways. But now we see power of the special right triangles again. Also, power of points is important. And that was a number 21 on the test. Okay, I'll see you in the next video.